Now in this video, let us see about what is suspension. A non-homogeneous system which contain a solid which are dispersed to a liquid are called as suspension. So a suspension is nothing non-homogeneous system in which the solid are dispersed in a liquid are called as suspension. So a suspension is a heterogeneous mixture. A suspension is a heterogeneous mixture in which the particle of the solid do not dissolve but remains suspended throughout the bulk of the medium. That means all part of the medium these particles are suspended, then it is called as a suspension. So particles of suspensions are visible to the naked eye. Now let us see what are the properties of a suspension. Suspension is a heterogeneous mixture. The particles of suspension can be seen by naked eye. The particle of a suspension scatter a beam of light passing through it and make its part visible. That means when a light is passed through a suspension, it scatters light, and the solid particles settle down when suspension is left undistributed. Suppose if you keep longer time, the particle which is in the form of suspension will be automatically settle down due to gravity. That is why we can say that a suspension is unstable. So the suspended materials can be separated out by filtration. When the particles settle down, the suspension breaks and it does not scatter light anymore. This is what about the suspension. Now we will go to the colloidal solution. What is a colloidal solution? Now let us see the mixtures. A colloidal solution is a heterogeneous mixture and in which the size of the solid is exactly 10 to the power minus 9, that is 1 nanometer. That is what we call as a colloidal solution. Because of smaller in size of the colloidal particle, we cannot see them with our naked eye, but colloidal particle can easily scatter a beam of light. The scattering of a beam of light by a colloidal particle is called as Tinder effect. So Tinder effect is nothing, scattering of a beam of light by colloidal particles. That is what we call as a Tinder effect. Tinder effect can also be observed when fine beam of light enter in a room through a small holes, and when a beam of light comes through a small holes where dark room is there, then on that ear the dust particles are in the colloidal size, you can see it easily. So this is the picture which we have seen, that is about your Tyndall effect, how a beam of light scattered by Tyndall effect. Now we will see the next page, that is page number 18. In page number 18 we will discuss about the Tyndall effect phenomena and the uses of colloid. Tyndall effect can be observed when sunlight passes through a dense forest where water vapor is there, and water vapor act as a here colloidal particle. So you can see the images. In the image, your tree which is grown up, you can observe as a tree goes inside the root. That means in opposite directions. This is because light scattered completely in opposite direction, that is in 180 degree. That is why you can see altered. This is there. Now the properties of colloid. A colloid is a heterogeneous mixture. The size of the particle of a colloid is too small and thereby individually we cannot see it by naked eye, but as a group you can see it. Colloidal particles are big enough to scatter a beam of light passing through it and make it the part visible. So when a beam of light is passed through the colloidal particle, you can see with the scattering of light, and they do not settle when left undistributed. That means colloids are quite stable. So they cannot be separate from the mixture by the process of filtration, but for the separation of colloid we need to use a term which we call as a centrifugations. The colloids have two components. First component, that is dispersed phase. Another one is dispersion medium. So what do you mean by dispersed phase and dispersion medium? Let us see it. Solute-like components or the dispersed particle in a colloid form the dispersed phase. That means solute-like substances which is in the colloidal size that we call as a dispersed phase, and the component in which the dispersed phase are distributed that we call as a dispersion medium. Colloids classified according to the state, that is solid, liquid, gases of the dispersion medium and dispersion phase. So based on the dispersion medium and dispersion phase, we can classify a colloid. So let us see some examples of colloid. We have here liquid, gas. Liquid is a dispersion phase and gases is a medium. Then we get aerosol type, and in aerosol type we can take the example fog, cloud, mist is the example of aerosol, in which your liquid is the dispersion phase and medium is of gases. Same thing like this, we have solid gas colloid is also called as aerosol. The example of solid gas aerosol is smoke, automobile exhaust. These are the solid gas colloid. And your gas liquid colloid, where gas is the phase and liquid is the medium, then we get the example foam. Example is your shaving cream. And again we have liquid colloid. Liquid colloid, we can take an example emulsion. Emulsion is nothing, it is a liquid colloid. As you can see, emulsion, when you mix oil and water and shake well properly, so a group of liquid clustered together like a ball, that we call as an emulsion. Example which you can see, take it as milk and face cream are the emulsions. Like this one, solid, liquid, sol, which we can solid is the phase and liquid is the medium. Then you get sol type of colloid. In example of sol type of colloid is magnesium, milk of magnesia, or mud, you can say. Like this one, gas solid colloid. Gas is the phase and solid is the medium. Then we get type foam. Foam examples we have seen here: foam, rubber, and sponge or pumice are the examples of gas solid this colloid. Next, liquid solid colloid, we can say gel. So in gel, your liquid is the phases and solid is the medium. And example, jelly and cheese or butter, you can take it. Something like this one, if you have taken solid colloid, then we call it a solid sol. Your example is colored gemstone or milky glasses. These are the examples of your colloid. Now let us see separating the components of a mixture. So how we can separate a mixture of dye from blue or black ink? For that we need to do this evaporation. So in the evaporation process, those which have volatile components, those which are more volatiles, can easily goes as a gas, and your dyes are non-volatile, so they remains in the vessel. So like this one, through evaporation we can separate dye from water. As in the next video we'll see the